Okay. Good morning. So we can start with our host of today, that is Gerald Mills. There is some microphone open. Okay. So we start with our host. And Gerald Mills is oh, there isn't. Why? I lose. Just a minute, please. I find. Okay. I'm setting. Post. Okay. No problem. Okay. This morning we host Gerald Mills from University College of Dublin, and the speech is about climate resilient cities. So I face a really big problem for smart cities. There are climate change, and because it's our the big problem we are facing today, and I'm convinced that after this health emergency, we'll have to face this problem, and will be bigger, I think, of the health emergency. So, Gerald, floor is yours. We have unfortunately, only 1 hour, but I think it will be very interesting to hear from you your vision about we can create climate resilient cities. So join the resilient paradigm with the smart paradigm. Please. Thank you.
Good morning, everybody. Hello from Dublin. It's 8 o'clock in the morning here. It's a nice day outside. What I'm going to talk about are about creating cities that are more resilient with regard to climate. And I think, as Luigi has indicated, that's a very good time to begin this conversation precisely because of the pandemic. And for many of us, it's causing us to question how our cities are constructed.
And Gerald, so I'm sorry, can you check if your subtitles are active? Because we cannot see.
Sorry, I have to leave for a moment then. Stop share. So let me see here. Home. So I'm in subtitle setting. Oh, always use subtitles, I guess. Let me try that again now. Okay, does that help?
You open the presentation to see the subtitle.
Sorry. Yeah. Is that okay now?
Perfect.
Okay, apologies. As I was indicating, I think Luigi brought up a good point about the nature of cities, particularly during the pandemic. I know for a period of time here, during the summer, everybody was restricted within 1 kilometer of their home. And I think for the very first time, a lot of people discovered what was within 1 kilometer of their home was not a very nice city. So it's actually started a discussion about how to improve our cities to make them more healthy. And I would argue that a healthy city is also one that's probably more resilient to climate change. So I'm going to start with what exactly we mean by resilience. In general, it's taken to mean a place that can recover. In other words, following a crisis of some form, in this case here, a climate crisis, the city can recover. So it's long been a dream of cities that they can protect themselves against all sorts of weather events. I'm starting out with an image of an area of Manhattan, New York, and a hypothetical dome designed by Buckminster Fuller that would actually enclose the entire downtown area. Of course, this was proposed during the 1960s when it was felt there was going to be a period of the future with unlimited energy. The idea behind this was that the dome itself would effectively turn downtown Manhattan into one enormous building, effectively. Light would obviously pass through, but the city would be effectively protected. Buckminster Fuller calculated it would pay for itself within 10 years simply by saving the costs of removal. Of course, these types of ideas are fanciful. What I'm going to do is I'm going to talk in general about the nature of hazards that cities face. I'm going to take it from two perspectives. One perspective is from the perspective of global climate change. The other perspective is from the city itself. So I'm going to put two things together. One is top down and the other is bottom up. Now, my expertise, I'm a climatologist, but I'm also a geographer. My expertise is largely in the area of climate change in cities. So I'll draw on information that comes from another community, the global climate community, to talk about what climate effects on cities would be like. And then I'll talk about how they're added together to affect the climate that people experience within cities. So I'm going to draw on two different types of literature. And here's the first type. It is, I think, beyond dispute that the climate is changing. And I think it's also beyond dispute that a big part of the reason why it's changing is because of human actions. This diagram on the right is a very famous diagram. It's observations of concentrations of carbon dioxide. Carbon dioxide is a greenhouse gas. It's a very, very peculiar gas because, in effect, carbon dioxide does not absorb energy from the sun, solar energy, but absorbs energy from the earth, terrestrial energy. Because it absorbs it, it recycles it. So if you put more carbon dioxide into the system, inevitably, there's going to be warming. So this sawtooth pattern that you see here represents measurements of carbon dioxide in parts per million on an extinct volcano in the middle of the Pacific Ocean. So the values you see here globally now are over 400 parts per million, whereas where they began these measurements back in the late 50s, the values were just over 300 parts per million. In fact, if we go back further, that's before we actually had measurements, so we have to evaluate the amount of carbon dioxide using proxies, then the value at the time of the Industrial Revolution, thereabouts, about 1750, was about 270 parts per million. So this is why people say we're on the cusp of a double CO2 atmosphere, and the consequence of this almost certainly will be warming, simply because carbon dioxide is a greenhouse gas. By the way, I'd like to point out here that the measurements of CO2 that you see here at over 400 parts per million in the global atmosphere, you would routinely have measurements within cities of over 600, 700 parts per million, depending on what part of the city you're in. At a global scale, carbon dioxide is regarded as a severe problem for the planet. At a local scale within the city, carbon dioxide is not regarded as a pollutant, so we don't normally measure it. It's not the only greenhouse gas. The basket of greenhouse gases contains a number of different chemicals that are in the atmosphere. Carbon dioxide, which is shown in the upper part of this diagram, is the most prominent and is the one that dominates the warming effect. But there's also CH4, which is methane. There's also halocarbons, which include human-made chemicals like CFCs. There's also nitrous oxides, carbon monoxide, volatile organic compounds, and so forth and so on. How do you compare them? Well, a classic way of trying to compare them is by measuring their net effect on the planet. So in the latest Intergovernmental Panel climate change reports, what they use is this idea of radiative forcing. In other words, they treat each of these gases as though it were an actual energy entering the system or leaving the system. So you'll notice that the CO2 is positive. But as I move down that chart, you'll see that mineral dust, which is put into the atmosphere because of human pollution, also potentially has a negative effect. You'll see that cloud adjustments due to aerosols, which are tiny particulates in the atmosphere, also has a negative effect. But when I add all of these up, all these different contributions, you can see the total anthropogenic effect, that's radiative forcing relative to 1750, is still positive. The value we have here in 2011 was 229. So this is the additional energy in the system. That is watts of energy for every square meter of the atmosphere surrounding the planet. This is the additional energy that's pouring into the atmosphere on a routine basis, or is trapped inside the atmosphere. So the inevitable consequence of more energy within the system will be warming. So where does all this stuff come from? And this is where cities come into play. Globally, about 20%, 25% of all the energy that goes into the system via carbon dioxide is from buildings. About 30% is from transport, about 30% is from industry. Drivers of the system is the increased contribution of buildings to this emission. You notice that in the center there, they talk about CO2 EQ, and that represents equivalent carbon dioxide emitted into the atmosphere. I lost my camera here. Let me just switch cameras to the integrated one. What are the consequences of global climate change? Well, it depends, of course, entirely on what path we take from this point onwards, which is the whole point of the Paris Agreement, which is designed to limit emissions into the atmosphere and try and restrict the degree of warming that does occur. On the left-hand side, what we have is the global temperature anomaly. And what it indicates is, as we increase the amount of carbon dioxide into the atmosphere, what I can expect in terms of global temperature change. So you can see that there's not just one curve here, there's a whole multiple. I think I'm speaking loudly, so I'm not sure whether I'm still...
No, Gerald, I think that is a problem with the microphone, not your voice, because maybe you change the microphone that you are using. It's possible.
I can hear you perfectly. Can you hear me at all?
Yes.
So am I still too quiet?
No. I think that problem
is it fixed now?
It's not that. You change microphone or camera? perhaps?
Well, because the internet went unstable, so it switched cameras on me.
Okay, the problem, I think that you switch the camera and for some reason this switch is not good for PowerPoint. Other times we have the same problem.
But can you hear me? Can everybody hear me clearly now?
Yeah, we can hear clearly, just the subtitles there aren't, but isn't a problem. Continue.
Okay. So one of the effects, obviously, of increasing carbon dioxide into the atmosphere is that we can expect global warming. Now, the type of warming and the amount of warming we expect depends entirely on the amount of carbon dioxide and the other greenhouse gases that go into the atmosphere. Because we don't know the future of the planet in terms of how much carbon dioxide equivalent that we put in, what we have is we run models according to different types of futures. So what you see here on the left-hand side is what's referred to as representative concentration pathways. And the little value next to it, like 2.6 or 4.5, indicates the amount of radiative forcing that I expect as a consequence. So for example, you notice that the first set of lines you see here represent the period of time for which we have measurements. That's the area that's in black. So the last measurement we have there is 2010. And the envelope around that indicates how the models are reproducing that value. How we go into the future depends a great deal on how much carbon dioxide we put into the atmosphere. In the worst possible case, we get an RCP, a representative concentration pathway that results in a radiative forcing of 8.5 watts per square meter. There you can see that by 2100, the models are predicting a temperature increase on the planet of over 4 degrees Celsius. The objective of the Paris Agreement is trying to limit the amount of carbon dioxide emissions to try and make sure the RCP is as low as possible. Now, if you increase the temperature of the atmosphere, you also increase the temperature of the ocean. That means that the ocean water expands. Now, there's lots of reasons as to why the sea level will rise, but thermal expansion is the main one. So on the right-hand side, you'll see the other consequence. We're almost certain that increasing the warming of the planet will result in sea level rise. The amount of sea level rise, as you can see, depends entirely on how much carbon dioxide is put into the atmosphere, because that's what governs the concentration pathway and the radiative forcing. And much of global climate change literature is expressed in terms of risk. So the risk is essentially the risks associated with infrastructure and with human populations as a consequence of global climate change. So we describe risk as at the intersection of vulnerability, hazards, and exposure. So the hazard represents, of course, the science of climate. So one of the outcomes of global climate change might be more frequent and more powerful hurricanes. So that represents a change in the hazard. Exposure represents the extent to which a population or infrastructure are literally exposed to that hazard. So cities which are located in the tropics, close to coasts, are exposed to the hazards of hurricanes. Vulnerability represents the capacity of the individuals and infrastructure in the system to recover from an event that happens. So when we talk about resilience, we try to basically reduce vulnerability. There's very little we can do about many hazards. Some we can change. And if we've already chosen to live next to the coast, then we're already exposed. On the right-hand side, you'll see the things that control risk. So there are adaptation and mitigation actions that we can take on that can modify the type of risk we experience, the decision-making process we make on socioeconomics, change the emissions, change the land use, and that drives anthropogenic climate change. So in fact, the entire global climate change community concentrates on trying to adapt and mitigate by changing socioeconomic pathways and through governance structures to try and manage risk. So what has that got to do with cities? Well, there's two reasons why cities are centrally involved in all issues associated with climate change. The first is that although they occupy just 3% of all the land area of the world, cities are responsible responsible for more than 70% of the carbon dioxide emissions. So on the right-hand side, I have two diagrams. The diagram above is population on the planet on 1 square kilometer resolution. And the diagram below shows commercial carbon dioxide emissions, again by square kilometer. What you'll see is that the emissions are largely concentrated in the wealthy cities of the world, mostly in the Northern Hemisphere, but some cities in the Southern Hemisphere. So cities are major drivers of climate change. So if I want to mitigate, I have to focus on cities because that's where the emissions are coming from. However, cities are also located in extremely vulnerable, exposed parts of the world. Most cities are located close to coasts. Most cities are located in low-lying areas that are subject to flooding for obvious reasons. Because in the past, cities would have chosen locations based upon ports, based upon access to water. So we have two things happening here. One is that cities are largely responsible for the carbon dioxide emissions into the atmosphere. Therefore, that's where we should focus our mitigation efforts. The other thing is that because cities themselves are located in vulnerable, exposed areas, it means then that this is where adaptation should also focus. So I would argue, frankly, that if you want to alter global climate, the best place to start is in cities. So this is where this idea of smart cities, resilient cities, green cities, and global climate change comes together. So mitigation has fundamentally got to do with reducing emissions into the atmosphere. So not surprising, we look for changes in the landscape that can accomplish that, such as, for example, switching from private cars to public transportation systems. The image on the left here comes from Curitiba, where the road system is largely dedicated to a public transportation system, which operate on these separate corridors. And what you're looking at here are bus shelters as people pay to get on the buses. It also means that the buildings themselves, which are major drivers of emissions within cities, start to switch to other approaches to gather energy. This is Solar City in Freiburg, where the buildings themselves are oriented in such a way and built in such a way that they all get access to sunshine, so the rooftops are effectively solar generation panels. An example on the right-hand side is one of the major initiatives associated with making cities more resilient, which is to make cities greener. So typically, this greening is expressed horizontally through parks and forests. This example here from Milan actually is quite innovative. The idea is that the greening extends vertically. So this has two effects. Trees take in carbon dioxide. That means they mitigate or offset some of the emissions that occur within cities. The other thing is that trees also act as sort of natural air conditioning units. So the idea behind this particular design is that the individual units get their own natural air conditioning system simply because they have vegetation adjacent. So mitigation is one of the big pushes in global climate science. However, it's inevitable because of historical actions that the climate will change in the future. So this will mean that the statistics of rainfall, the statistics of flooding will all change, and we might have to change the infrastructure of the city to cope. Here's two examples of adaptation options. The one on the left-hand side comes from a park in Singapore. Here they've decided to resurrect a river system and allow it to run as a linear path through the city itself. And this places capacity in the system so that if the river gets excess water, it can flood without damaging the urban infrastructure. It also creates a park which allows for relief from excess heat for the local population. The image on the right is the Thames Barrier in London, which is a device a bit like the one that's just been established in Venice that protects the city from excess water. Now, the Thames Barrier was actually designed in the 1950s, but been reconditioned now to adjust to potential climate change and sea level rise. So this is what climate change tells us will happen to cities in the future. First of all, there'll be warmer or fewer cold days and nights over most land areas. There'll be more warm spells and heat waves. Both of these are strongly evident in the data so far. So this means that effectively, we will have to adjust our cities to cope with a different type of climate. So for some cities, which are experiencing hot weather, the increased heating in the atmosphere result in more heat wave events. And though most people don't realize it, heat waves kill more people annually than any other natural event, including hurricanes, tornadoes, earthquakes. It's heat waves that kill most people. We can expect more heavy precipitation events, more intense rainfall events. And at the same time, it's expected there'll also be more droughts. So rainfall will become more infrequent, but more intense when it occurs. The evidence on tropical cyclone activity is not very strong at the moment, but this is an interesting year because we've certainly the Atlantic hurricane season. We are now well into the Greek set of names because we've run out of the names that we normally give to hurricanes. And then, of course, we do know that there will be sea level rise. So when you think about cities, cities are already warmer than the natural environment, so we expect more warming. Cities are already paved, which means that most of the water that falls in the urban landscape is diverted. Now we can expect more rainfall. Cities are already located coast to coast, and we expect there to be sea level rises. So clearly, global climate change has a specific impact on cities, where we've concentrated all the people and all the infrastructure. Okay, now I'm going to switch slightly to tell you that, in fact, climate change has been occurring on the planet for generations, for hundreds of years. Until recently, the 1970s, 1980s, the only identifiable human-caused climate change occurred within cities. In other words, local climate change. And that local climate change, excuse me, is associated with the nature of the city itself. There's two main things that control the climate within the city. The first is its physical form. That consists of the fact that most cities are intensely paved, which means vegetation is removed. Most cities have fabric which is designed to be dry. In other words, the fabric, its first duty is to get rid of water as quickly as possible. So that means when I lay out a city, we also have to lay out an artificial hydrology system that can remove the water. And cities also have a geometry. So if you look at this image here from Singapore, in an alley, there's no vegetation. There's a three-dimensional shape here. It's got an orientation, which is the street. This governs access to wind, access to light, access to sunshine. The other thing about cities is their intense concentration of urban functions. Those urban functions generate waste heat and waste materials. So again, if I return to the Singapore picture, you can see endless number of individual air conditioning units attached to each of the buildings on either side of the street. Each of those buildings is effectively a refrigeration unit, and the waste heat in the form of water vapor and heat, temperature, is pumped into the outside atmosphere. In other words, each of these buildings is creating an internal climate for itself, but by doing so, it's actually creating a worse climate for those outdoors. So cities intensely, profoundly modify their climates. So not only do we have to deal with global climate change, but we also have to consider the effect of local climate change, so decisions that we make inside individual cities. If I look at cities, this is a picture from where I'm near now at the moment. This is Dublin. It's not a very, very intensely developed city. If I take a picture from a city centre, what you see is it's primarily paved. You can see very little vegetation within the city itself. That means the city responds completely differently to a natural environment, to the energy that it receives from the sun. As I say, the purpose of the city is to function consistently through time, and the way it does that is by creating a landscape that's effectively weatherproof, that does not vary. This means that small pockets of parks, that's shown on the right-hand side here in the centre of Dublin, represent refuges from urban climates. And the urban climate is demonstrably different from the climate outside the city. I say cities, but of course the type of city you get depends on how it's constructed. On the right-hand side, I have two images. The first one shows Tokyo, a city which has more than 30 million people in it. And you can see it is absolutely intensely modified. The landscape here is utterly transformed. There's very little vegetation present. Now, here's the thing. This city will generate an awful lot of emissions into the atmosphere, but it does so quite efficiently. And does so quite efficiently simply because so many people are concentrated in such a small area. That means there's all sorts of capacity within this system, for example, for public transportation to ensure the city can actually function efficiently. At the same time, the impact on a square kilometer basis is colossal. Tokyo's climate is intensely different from the climate that would be there if it was not for the city. The image on the lower side is suburban Chicago. So most of Chicago, when you look at it, is actually quite a suburban landscape. Here you can see individual pockets of houses. You can also see the grid system, the road system that underpins the basic infrastructure of the city. But you also see lots and lots of trees. In fact, pictures of suburban Chicago during the late autumn months technically classify as a forest. Here we can see that there's low impact at a local basis, but nevertheless, in order to traverse this landscape, there's very high impact on a per capita basis. So from a global climate point of view, the compact city, the more intensely occupied city, is more efficient. On the left-hand side, the very, very well-known diagram, which shows two cities, one of which is Atlanta in the United States, the other is Barcelona in Spain. They both have almost equivalent populations, but you can see they occupy dramatically different size areas. Whereas Atlanta covers well over 4,000 square kilometers, Barcelona just 162 square kilometers. Now, there's lots of efficiencies that come about because of that. It means that it's much easier to provide infrastructure for Barcelona than it is for Atlanta. It's much easier to provide public transportation systems. So in the global climate world, cities should look much more like Barcelona and much less like Atlanta, more like Tokyo, less like suburban Chicago. Now, here is the conundrum we face. Because what we want to do is create cities that we want to live in, that actually provide pleasant environments, and yet at the same time, we want the total emissions or effect of the cities on the planet to be reduced. So what do we associate it with the climates within cities? Well, effectively, the climates inside cities are characterized by enormous microscale climate variation. And this means that it's almost impossible to put a weather station inside a city such that it can actually capture whatever it is experiencing. This example shows a windstorm in Tokyo. One individual is struggling to walk up a road, while another individual, no more than a meter away, is standing in utter calmness, looking at him. So that enormous variation happens over very short distances. Because cities are paved, because they've got relatively little vegetation, much of the heating associated with the sun is converted into heating the atmosphere overhead, not into evaporation. The consequence of this is something called an urban heat island. So urban heat islands represent the fact that the cities are almost invariably warmer than the areas around them. Now, these temperature variations can be quite large. On the right type of day, the temperature difference between the city and the outskirts can be on the order of 10 degrees Celsius. Now, this is a natural occurrence that occurs at the local scale simply because of the urban landscape. The effect of global climate change will be to enhance urban stress, which is already associated with the urban heat island. So if you don't have vegetation, and if you've got paved landscapes, then what happens is you have to somehow take care of the hydrology. So the hydrology in cities is profoundly modified. Much of the hydrology occurs below ground. Much of the hydrology has been created by humans in piping systems to make the system as efficient as possible. The consequence is that cities respond very, very quickly to rainfall events, often causing flash flooding. So now we have heating, hydrology, as major microclimate impacts as one of the major effects of cities, all of which have been associated with the form of cities. And of course, associated with the functions of cities is extremely poor air quality, which is ubiquitous. So one of the major, most dramatic impacts of the COVID crisis during the early part of the summer was the shutdown of many industries in parts of China and parts of Europe, and a dramatic improvement in air quality. So these are the local conditions that we're trying to deal with at the same time as considering global climate change. So if you went back to the chart I showed you before about governance, essentially by trying to manage the global climate change, we're trying to regulate at the moment with decisions that occur at regional and national scales, such as the Paris Agreement. I'm arguing that in fact cities are core parts or should be core parts of that decision-making process. That decisions that cities play out at neighborhood scale is where we make decisions about the types of buildings, about the layout of buildings, the amount of car park space to build, the amount of green space to provide. And then ultimately it comes down to the scale of the individual who has to make decisions about heating arrangements inside the house, cooling arrangements in the house, and the use of transportation systems. So one of the big issues is how do we actually manage that across the spectrum, from the individual, the personal, all the way up through nation states and cities, up to the scale of the planet itself. So what principles will we need to apply to achieve some form of climate resilience? In this respect, I'll talk about the New Urban Agenda established by the United Nations, and the role of one organization that I'm involved with called the World Meteorological Organization to try and provide infrastructure, scientific infrastructure, to the creation of what they refer to as resilient cities within the New Urban Agenda. The principles I'll talk about just briefly are, first of all, the establishment of a scientific infrastructure so that we know that when we make changes to the city, that we get the benefits we expect. The need to identify desirable action within the city to outcomes that we want explicitly. I want to emphasize the importance of scale, simply because we often forget that these interventions at different scales have interactions with other events at other scales. The need to meet goals simultaneously. And by that, I mean that we do want to address global climate change, but we also want to create spaces within cities that are healthy, that are comfortable. Especially, I want to emphasize the role of urban design in creating an urban form and function that actually is resilient. So I'm going to just use lots of examples drawn from different parts of the world to try and illustrate these ideas. So this is the first thing. How do we create a scientific infrastructure? Well, in effect, until very recently, there's been absolutely no meteorological, hydrological system capable of coping with changes at a local scale. So one of the big challenges we face is trying to link together what we know about the global climate change and establishing a hierarchy to connect it all the way down to the level of a city. So what we've ended up with inside cities is individual systems to try and protect or manage risk. So for example, we might have measurements of air quality. We might have measurements of urban hydrology, but we don't necessarily integrate all this information together. So the goal behind this integrated urban hydrometeorological climate environmental service, which has been spearheaded by the World Meteorological Organization, is to try and come up with specific urban services. In other words, to try and find out the sweet spot, which includes information about air quality, about hydrology, about heat waves, etc., and identify everybody within the urban community with a vested interest in managing the urban system. And the idea would be that you'd actually develop an integrated urban service specifically designed for that city and the risks that it faces. There are examples of this. For example, Singapore has its own meteorological service. So separately from the Chinese meteorological service, there's one specifically set up for managing climate-related services within the city of Shanghai. So if we are going to design more resilient cities and smarter cities, it will mean that we have to get down to the elements that are actually driving the city itself. Fundamentally, it comes down to the indoor and outdoor spaces and how they're managed. You've seen the example here on the left-hand side of Freiburg, the solar city. The upper diagram shows solar city from above. Here, the buildings are designed such that they all have equal access to sunshine and the resources that they need to create an indoor climate suited to their needs, and not interfere with the rights of other citizens to get the same energy. In the upper right is an area called the Beddington Zero Energy Development, which is just outside London. What you're looking at here is photovoltaic cells, a building which is designed to access light. And what you're seeing on the rooftops here are not chimney pots to get rid of heat. They are in fact ventilation shafts to suck in air from outside to actually clean out the air within buildings. In the lower left-hand box, you'll see a vegetated building located in Singapore. The idea behind this is a bit like the Milan building, is that vegetation is incorporated routinely into the building system. Now here's the thing, a great deal of the design options that we have, we've known about for hundreds of years. So the use of covered arcades, which you see in the bottom right-hand corner here, are a classic example of managing climates in hot climates through simple design processes. And here are various types of design interventions to try and create comfortable outdoor spaces. The one in the upper left-hand corner is actually in Dublin, where the chief issue here is associated with rainfall. What you're looking at there is an outdoor space that's comfortable for people to go outside, because the umbrellas that you see here actually work to gather rainfall before it falls on the ground below. The image on the upper right is an unfortunate consequence of buildings that are extremely tall in a cold climate. Because the buildings are so tall, they bring down very, very fast air to the surface of the street. So what they've done is they've put these artificial trees in place to try and block the air moving down off the buildings. The bottom left, you see an image from Munich, which shows a vegetated street. Vegetation is the most versatile tool by a long way in terms of managing climates within cities, because the vegetation provides shade, and if it's deciduous, the leaves are gone in the winter, so it allows sunshine. The trees take up soil moisture from the ground and interact with the atmosphere. The trees take away pollution. They also remove carbon dioxide. On the bottom right-hand side is from La Palma, where the very, very simple technique. During a hot day, they simply place a series of covers atop the the street itself, providing a nice shaded environment. These are simple techniques to respond to climate variations at urban scales. Water is probably the most powerful, apart from vegetation. Water can be inserted into the landscape in all sorts of ways. In the upper left-hand corner is a famous river in South Korea that was for years hidden because it was covered by a highway. They've now converted into a linear park. The advantages of it is, first of all, again, outdoor space that can be used. Outdoor spaces that have water tend to be cool, which means that they offer opportunities for people to recover from heat wave events. But because it's the river system that now has banks on it, it can actually respond naturally to the flows of water. In the upper right-hand corner is a development in the centre of London called the Barbican, where they use water routinely as a means of providing outdoor comfort spaces. The image on the lower left shows response to heat wave events. There's a Nîmes in France, where they have outdoor water functions that are available for people to relieve themselves during the summertime. And at a very, very small scale on the right-hand side, you see a set of sprays outside a shop to create a very, very small space that's cooled. Now, all of these are simple techniques that use either natural systems like water vegetation to achieve some form of resilience. Now, what do I mean by resilience in this context? Well, essentially, the spaces I've indicated here are spaces that can be used during heat wave events to offer comfort to individuals. I said vegetation is the most versatile. In every single climate, one of the most effective ways of counteracting the effects of cities is simply to put in more vegetation. Again, in the upper left-hand side is Lezione in France, where they use vegetation throughout all the street systems. But this offers great possibilities because it means that the residents themselves walk around the streets are effectively separated from the emissions from cars. In the upper right-hand corner, we see Singapore. Down below on the left, this is a corridor of trees created along a street in the middle of Gothenburg in Sweden. Again, it creates a shaded outdoor space for people to use. And the bottom right, lots of spaces have dual uses. This is the light rail system in Milan, and it's got a beautiful set of trees all along its corridor itself. So there's a system that utilizes the space both for public transportation, but also represents a green corridor. This helps with regard to hydrology, helps with regard to temperature, helps with regard to biodiversity. So let me just draw some general conclusions. First of all, global climate change is driven by economic activities that are concentrated in cities. So that's where all the energy is being used, consumed in transport, in buildings, and in industry. The net consequence of all that carbon dioxide emitted into the atmosphere is to change global climate. The impacts of global climate change in cities would be dramatic. The reason for that is simply because of where cities are located, close to coasts, low-lying areas, but also because of how cities are built. Mostly paved, very little vegetation, etc. At the same time, cities affect local climate profoundly because they change aspects of urban form and functions. That means that most of us have to deal in cities with various forms of environmental degradation. Now, some of the solutions to sorting out local problems are simply to create lots and lots of green spaces and low density development. But the consequence of that is I end up with a high local air quality, high local environmental quality, but I need more energy simply to traverse the space. So the challenge is to try and make cities compact, to make them more densely occupied, at the same time as reducing the amount of environmental degradation that occurs locally. So that for me is the big challenge associated with creating smart cities and resilient cities. It is both to manage risk at a local scale and also to manage risk at a global scale. And I'll finish there, thank you. I'll finish with this image here, which I think shows you the issues that we're facing. This is Cairo. Obviously, if I want to make people's lives here improved, I would be separating out traffic from people. I try to make it less crowded, but the consequence of that may be to make the contribution of Cairo to global climate change much greater. So here is our challenge. How do I actually address issues that occur at a local scale in cities, at the same time address issues that affect global scale climate change? Thank you.
Thank you very much, Gerald. This last slide, I think, is a perfect synthesis of the problem we are facing. How to face, how to join a global problem and face this global problem with local actions. So I think we have to think about that, to think the way in which, I'm sorry, I have to share my screen. Sorry, just 1 minute. So, I didn't find it. Oh.
Well, I think you're right, Luigi. I think that to some extent, I mean, the material, some of the things I work on at the moment are about individual buildings. And if you look at how we actually try to manage individual buildings, we treat them as almost as separate units, and we try to make every single building as efficient as possible. Now, here's the thing. That doesn't work inside cities, because in cities, every building is connected to every other building. via exchanges. So a far better approach would be to treat the city or these parts of city neighborhoods as individual entities and try to make them as efficient as possible and as resilient as possible. So to make resilient cities, not by trying to make one building at a time resilient, but by making neighborhoods more resilient.
Yes, I like to give the floor to the participant to have some reaction, some comments or question, if there are. It's a digital breakfast for us too. I check in the chat. Prego, Valerio, you are welcome. Valerio asked to, is it possible to do a consideration reflection? Valerio, you have to open your microphone. Valerio? Alessandro, Valerio is online?
Sì, penso stia scrivendo nella chat. No? Ok, sì, ha aperto il microfono. Prego, Valeria.
Try today, Valerio.
Mi sentite? Prova.
Ok.
Ok, ho tolto le cuffie, erano le cuffie il problema.
Okay, now we can.
Okay, nice to meet you. First, I want to make one consideration. I believe the problem is also how do you approach the problem, because if you think about Los Angeles and, for example, Vancouver, British Columbia, they are really similar in how the city is developed, how the environment is built. You have downtown, and then you have extremely, and maybe for some one of us who are Europeans, ridiculously wide cities. Downtown, and then you have kilometers and kilometers of small single houses or big single houses, but the approach is totally different. In LA, for example, everyone moves with car. If you use public transportation, is impossible to move. It takes 3 hours by subway to get from a point to another point in the city. On the other hand, in Vancouver, British Columbia, is 600,000 people cities. From a point to another of the city, the extreme points is about 25 kilometers. But at the same time, most people use public transportation because the politics made certain decisions. The new buildings have to be very efficient to be big, to have the permit of building. So I think it's not just about big city, small city, concentrated people in a place. Or
well, I would agree. I would agree with you that it's not just that, but it is part of that. I mean, Vancouver is not a model that I would use for other cities. It is colossal, and there's lots of parts of Vancouver that you cannot access through using public transport. And Los Angeles, if I was to, because I lived in Los Angeles for years, if I was to say it on its good side, it does actually have a public transportation system. It just is huge, absolutely huge. And it's also got a population of over 30 million. So And here's the other thing. You're absolutely right regarding the considerations for new buildings. But let me put it this way, about half the stock of all the buildings in Europe were built before the 1980s, before there were any regulations about energy use inside buildings. So they still form half the stock. Now those buildings will be there here in 50 years' time. So it won't be just a question of building new buildings that are very efficient. We're going to spend an awful lot of time trying to fix older buildings. And from what I can see in the cost of repair of some of these older buildings, we'll have to make real decisions about whether, in fact, it's even going to be possible to afford to fix all those buildings. So I think we need a different approach to how we manage energy use in buildings, as well as you point out, considerations about public transportation systems. But many decisions about providing public transportation, a lot of those have been limited effectively by how the cities have been built to this point. So it's much easier to provide public transportation in a city like Barcelona than in Vancouver. Most of Vancouver's transportation system is based upon a bus systems, and it's very inefficient to put a subway system into a place like Vancouver because of its size, because of its low density once you get outside the city center.
Yeah. Yes, of course. In fact, it's too big. It's a fact that it is too big. But at the same time, I'm thinking about like you told something that is, I think it's very right. We think about how to efficient a single building instead thinking about efficient multiple buildings at the same time, like with cogeneration, etc. But at the same time, in a city like Tokyo, you cannot decide alone to make your house self-efficient because you don't have a roof where to put solar panels. You don't have yes, it's something maybe in a concentrated city you need to the administration must choose instead of citizen to be efficient. In your cities, it's the citizen who has to choose to be efficient. Well, I don't know.
I agree, but I also think that there's a scale in between the city and the individual where some of the most effective changes can be made. And that's at the scale of a neighborhood. To make a neighborhood more efficient, I think is partly to make outdoor spaces more pleasant for the people who live in the neighborhood, at the same time as addressing issues associated with where the work is in relation to where you live and in relation to how our places are built, how they're constructed. So I think it's possible to do it, simply because everything we've done to this point hasn't worked. We have to come up with a different way of doing it. And I do think that the neighborhood scale, where you actually have communities, is the best way of trying to achieve both what you describe as individual choice and also what I would describe as the urban need, which is to reduce energy consumption, resource consumption, and at the same time as produce a place that people want to live in.
I absolutely agree with you about the scale of action. The neighborhood scale is the best one, I think. But it's true that each situation needs a particular solution. So it's impossible to find a solution good for all the cities. So each one has to study, each one has to be analyzed, so to find the right solution for that situation. But
you're absolutely right. I think historically, culturally, how cities are built are different from each other. The background climate is different. So, for example, in my city, Dublin, excess heat is hardly ever a problem. Here, it's all about water management. Whereas if I was to move to a different city, like say Cairo, the issue might very well be not too much water, but too little water, and associated with overheating. So it needs a different solution.
Yes, of course. But we have to think what will happen in the next year. So in our case, we have the forecasting that are not so good in terms of improve of sea level, in terms of high temperature for the next year, next 50 years and so on. So we have even to prepare our cities, our societies to this change, and we have to start now.
Absolutely, and I think you can start with relatively small interventions to make outdoor environments more pleasant. And if you make outdoor environments more pleasant, then people spend more time outdoors than indoors. So I think those small interventions can happen right now with designations about appropriate greening strategies at community level. The big issues you describe, like protection from sea level, we'll have a very hard choice to make for some cities, which is whether we bother protecting some aspects of the city or let them go. And although Dublin might be a relatively well-off city and can afford to put up walls to surround the city and protect it, if I go to other cities like, say, for example, Dhaka in Bangladesh, there's no money available to do that type of intervention at the scale that's going to be required. So as citizens of the world, reducing emissions is the only strategy I think that's going to be reasonable to try and affect global outcome exchanges. And then after that, it's going to require knowledge transfer, and it's going to require resource transfer to try and adapt cities outside of Western Europe and North America. They're going to suffer the consequences.
There is another reflection from the floor. We have Gonare that put an interesting point on the table. A neighborhood landscape will produce also food. It's a good way. He means the garden not just to pleasant solutions, just pleasant, but also to product vegetable and so on. There are urban experience, like in Rome, there is a experience in that way at this moment. I think there are in other city for sure. It's a way. I think it's absolutely a way, because create this solution create also identity for the people, that and social community, a sense of community, and even answer to a need to produce food for the people. Not all, and even of course all the other positive effects that Gerard showed us in his presentation. I don't know, Gerard, if you like to.
I completely agree. The material that I read, I don't think urban agriculture will ever feed the urban community. I think it's more important as a means of getting social cohesion. And I also think that because if you've got green spaces, then obviously you offset some of the effects that you don't want in cities. But there's going to have to be a trade-off. I know this in my own city, that whenever people talk about planting trees in streets, it's a political decision. You cannot address all the problems of the city by simply having more vegetation. Ultimately, we're going to have to talk about the removal of cars from streets, at least parts of cities, because there's only so much space available. People talk about using the rooftops of buildings, but I do not see a great deal of value for rooftop spaces as a general strategy. So I think it's going to be discussions about how we use the ground spaces inside cities to have urban agriculture and to have green spaces. And think back to a previous point, if we have higher density cities, where people do not have their own private gardens, then it's up to the city, I think, to provide public spaces for people to have access to.
Yes, the trade-off is that, and the politician, the public decision maker, will have to face this kind of trade-off. And I think we have to participate in this debate. We have to think the solutions as scientists and as citizens too, because only I think only with a common debate we can solve this problem. It's impossible to solve and face this problem only from the top.
I agree completely, yes.
We have to show to decision maker that we are aware of the problem, and we are with our decision of every day we are facing the problem with little things, little actions, but each one is important.
The other thing I'd say is that I think an awful lot of the science is now there. In the past, you could argue that we didn't know lots of things. I think that's difficult to argue now. I think there's a great deal in what I refer to as urban climate science that's available and is applicable. The problem is a lot of that knowledge does not get transferred into actual decision-making processes to create cities that we want to live in.
Yes, but now we know, so there are no more choose to don't act.
Yeah.
Okay. If there are not more, oh, there is gonna is something I was thinking. Looking is Marina's neighbor with a lot of green space not used. Yes, Gonare, absolutely, it's a possibility. Because in the school we have a part of the school are the co-working lab, as you know, and I of course invite you to participate if you like in our discussion in the project of the groups, to give some idea or just to discuss and to give your opinion. I will. I think you do have already the link for the lab. If not, we'll send you.
Yeah, would you mind sending that to me, please?
Okay, and so Gunnar, I was thinking to use this solution for this project because there are a lot of green space not used.
Yeah.
And so to create urban space for the food, for feed. Essentially. It's a possibility. Why not?
Yeah.
But always with a balance, a correct balance, because there are several needs in the neighborhood: mobility, and so on. So there is, or just to walk. The public space are not only for one target. You have to reason in a complex way.
Absolutely.
So, Gerard, thank you for your time. Thank you for your very interesting, inspiring presentation. And so we wait for your presence in the co-working lab if you have time. And for now, thank you for this digital breakfast. And see you soon. Thank you very much.
Thank you very much. Thank you, everybody.
Thanks. Bye.